I am joined here today by the Astroscale fleet, including Elsa D in the lower right corner. Elsa D is our debris removal demonstration mission launching March 20th, and we are very excited about that. We at Astroscale US are also really excited to sponsor today's discussion with Paul Graziani of AGI. AGI and Astroscale have a great history of partnership and friendship, and I think it's because we share a vision of what's going to make space work well now and into the future. So a bit more about our speaker. Paul Graziani, of course, is AGI's CEO and co-founder. For more than 30 years, Paul has championed the use of commercial software in the national security and space industries. Today, AGI's flagship product, STK, is used in more than 50,000 installations around the world, spanning the aerospace, defense, and intelligence industries. From AGI's beginning, Paul has spearheaded work practices that have earned local, state, and national recognition. AGI's innovative work environment and the software produced there have won several entrepreneurial excellence awards. Paul is chairman of the boards of Cesium, OneSky, and Comstock. He sits on the board of directors at Basura Aerospace and serves as vice chairperson of the Federation of Galaxy Explorers. He's a director emeritus of the U.S. Geospatial Intelligence Foundation, a member of the board of governors of AIA, the Aerospace Industries Association, and an associate fellow at the American Institute of Aeronautics and Astronautics. Paul is also a former member of the Board of Governors for the Civil Air Patrol, and today he serves as a chairman of the Civil Air Patrol Foundation. In addition, he previously, and after fulfilling his board tenure, Paul was elected to the honorary position of Life Director of the Space Foundation. Paul earned a Bachelor of Science degree in biology from LaSalle College, but quickly pivoted his career by virtue of his software development skills, launching into satellite command and control systems with General Electric's Space Division in 1980. Paul is a serial early adopter of all technology, an avid woodworker, and a sports car enthusiast. Is that all you've had time for, Paul? Without further ado, our speaker today, Paul Graziani.
Yeah, thanks, Dave. I think that all means I'm just getting old. I will. Hey, I do have to respond to the partnership that you mentioned there with AGI and Astroscale. It's been terrific. It's been great to be associated with Astroscale US for quite some time now. We're so proud to be on that team. Your various missions between the space debris mitigation and the on-orbit servicing are just so critical to kind of where our whole community is going. So, as I said, we're just really very proud to be on your team. And I'll say thank you for sponsoring this event. It's kind of a great opportunity for us to get out and talk to a lot of the community here. I'll also have to say thank you to WSBR. Again, a lot of friends for a long time on Washington Space Business Roundtable. Such a great service that you provide, getting the word out for all these people and to the community. It's something, especially now during the pandemic, that's so critical. We're just not able to get together the way we had. And it's, events like this and bringing in people like General Dickinson to be able to speak to this audience is just great. So thanks. And again, thanks for this opportunity.
Thanks, Paul. So let's take you back to the beginning. So 32 years ago, can you tell us what inspired you to start AGI?
Yeah, so there were three of us, if we go back, and a long time ago, three of us working at General Electric Space Division. So GE had been developing the command and control systems, the mission planning systems, large ground stations for the large government satellite systems. And during that, it's a very complex process, and those systems need to work as intended. And so what we were doing is testing those systems by printing out all of the data that was associated with how those systems work. I remember one particular round where we had 86 test cases to run. Each test case produced this pile of paper. For the older people on the call here, you remember that green fan fold paper. So we would have stacks of those 3 feet tall, filled with numbers top to bottom. And we would have to go through each of those line by line to make sure that all of the data there was as intended. It was very tedious. So we would have to go and convert from one coordinate system into latitude, longitude, for instance. Then we would have to go up to a map and see where that lat long was and ascertain whether or not the end of one particular operation at some particular location and the start of the next was as it should be, as just one example. And it just took a long time. It was very inefficient. And so we decided that we would try to develop some software to graphically display all of that data as a means to much more efficiently, and as it turns out, really more effectively too, figure all that out. So we did that, and it worked. It worked really well. Our customers loved it. We loved it because it was just easier to do. But then at GE, we were working on several related programs, different, same customer, different programs. And the way government contracts work, we could not take that software that we developed under one contract and go apply it to another contract. And very frustrating. And we actually had to reinvent that software again on that other program. Over the course of 10 years, we ended up doing that 6 times. And now each time it kind of got a little bit better, but still it just seemed that something was wrong there. So what we did, we went to GE management. We came up with an idea. We said, hey, listen, why doesn't GE pay for this once? And then GE will be able to apply it to all these programs that GE is working on. And unfortunately, that didn't resonate with management. For one, it was the ground stations we were working on were $400 million a year contracts, and this was very small. And then secondly, it just wasn't in the business that GE was in at the time. So the three of us working that, myself, Scott Reynolds, who's still with the company, and Jim Poland, who left early on, decided to jump out and start up AGI. A word about Jim. Jim still, I hope you're online now, Jim, still closely associated with the company. We were fortunate that Scott and I and our wives didn't have any children at the time, and the wives were all working, kind of paying the bills. Jim, unfortunately, had kids in college at that point and couldn't go in the startup thing, not paying himself, so he had to go back to work. But that was really the original impetus back to start AGI 32 years ago now.
Well, as one of the engineers working back in the 80s with those reams of papers and those different coordinate systems, I can only thank you for your software contribution.
Yes.
So AGI has a very unique culture. Can you tell me a little bit about how that developed and where you think, what the impetus for that was? Sure.
Yeah, I guess, foundationally, we get to talk about this a lot. It is kind of unique, I guess, in certain ways, and we're, I guess, grateful that it gets recognized that way. I think fundamentally, our culture really came out of just a few foundational elements. So one, it was kind of 3 friends that went off and started a company, and then actually more friends came into that company. So one critical element was that we really liked being with each other. We liked working with each other, and that created a climate and environment where you can create kind of a great place to work. Another thing, credit GE. When we were working those programs, everybody was and still the same people, many of the same people still at it's now Lockheed Martin are just as dedicated to mission as they were back then, and so we took that with us too. So there was this dedication to mission that kind of was another foundational element. We felt it was what we were doing is really important, and we're going to do everything we can to make that happen. And then at the end of the day, the having the drive and just love to do what you're doing, that was really the 3 pieces, kind of the friends with who you're working with, a dedication to mission, and just really loving, really enjoying the software work, the work in space systems. that were foundational. And the other elements kind of were born out of that. So, things like, for instance, we started off with somebody started bringing in bags of M&Ms, and then that kind of evolved to pizzas. And then the next thing you fast forward and we have breakfast, lunch, and dinner here. And then that then provides this opportunity for employees to interact with each other in a way that's not just work, and they can cross over departments. Other things like again, we really like each other, and so one of the elements we found early on with young people living in apartments that didn't have washer and dryers, we thought that was silly that they were going to laundromats. So we said, hey, why don't we get a washer and dryer here at AGI? So all these other cultural elements just kind of sprung out of that, but it really was those foundational ones that kind of got us started.
That sounds great. So over the past few years, there's been a number of related businesses that have spun off from what you started. Can you describe them and how that happened, how the spin-off occurred?
Sure. So yeah, I suspect that most of the audience knows us because of what was originally Satellite Toolkit and then renamed later to Systems Toolkit. And that really had been the primary business. But over the years, other subcomponents that really weren't directly along that, what we now call digital mission engineering, started to form. So the first one, a company called Cesium, now a company called Cesium, really started as an alternate way to display graphics. So we needed, within AGI here, we need to be able to display our graphics on the web. And so a team started off to develop this completely independent, what now really is a geospatial information platform that includes visual displays in web browsers. And what happened as that team kind of began to develop internally here, they also realized that there was plenty of opportunity beyond the markets that we were focused on. So aerospace systems, satellites, aircraft, ships, et cetera. And so the little unit started to form internally here. And then after a few years, we realized that, hey, this is really a viable independent business. So let's take the people that were there, let's peel off the intellectual property, and let's charge them with some dollars and send them off on their own path. So Cesium has been out now for a couple of years, really doing phenomenally well, venturing into new areas, new products. Smart construction is a really big thing that they're working, which is really neat. Lots of areas and things like autonomous cars and other areas that were not going to be something that AGI got involved with. Second one is a company called OneSky. So internally, we were working with unmanned aerial systems a lot, doing the things that AGI still does with those, like mission planning, for instance, for UAS. But what that team started to see was a need for unmanned system traffic management, or UTM. And we realized that we had some unique IP, we had some unique expertise here that could really knock that ball out of the park. And so same thing happened there. We started that team up, and that's now what they're doing, very much an operational thing, which is different than the digital mission engineering that AGI had done. And the last one to spin out is the Commercial Space Operations Center. Actually, that's where I'm sitting now. Both OneSky and ComSpock are in the same building as AGI still. And ComSpock is the Commercial Space Operations Center, a place where sensors from all over the world feed in 24/7, 365 a picture of space, and that information gets processed and a picture of the space environment gets built that gets utilized for space flight safety and for national security needs.
So, having said all that, what brought you to the point of selling this precious company that you had created, AGI?
Yeah.
Give us some of your feelings and how that came about.
Yeah, you're right. Yeah, the feelings, that's an important aspect for sure. So I'll tell kind of the story of how it happened first. So we've been at this as we said at the beginning, 32 years now, and on the one hand, we felt that we were very, very happy with all of the customers that we serve. So if we go and talk to any of the 50,000 users of our STK or related products out there, they just tell these hair-raising stories about the kind of things that they do with their products and the things that they couldn't do if they didn't have our products. So we were elated about that. What we were not so happy with was our penetration of the market, to use kind of a business term there, or the better way I like to think about it, because it's really the more important way. We weren't happy with the number of people that we were really serving. Those 50,000 of, when you cut across all the land, air, sea, space, digital engineering, digital mission engineering users throughout the world, is less than 1% of the people who could be using those products are. And we tried pretty, on our own, various ways to get deeper access to that user base, but we just couldn't figure out how to do that, and we felt that we needed to do something different. So about 2 years ago, one of the things that we tried was we were going to go partner with larger companies who have a much larger footprint than we do, to see if partnering with them could provide better access to those marketplaces and therefore be able to serve more customers. Turns out Ansys was actually one of the very first companies that we spoke to a couple of years ago. And, we were a little naive about this, but they said, hey, listen, if you're going to talk to us about partnering, then we're going to need to talk about acquisition. And we kind of said, well, we weren't thinking about that. We kind of liked everything on our own, except for this ability to get to more users. So we stepped back a bit and we thought about what would it really take for this to be the right thing for us. And so we really developed these kind of 4 tenets that we looked at. So we said, geez, can we meet our mission, meet our goal of really achieving that founding vision, which was, we always imagined that we could bring a dramatic transformation of efficiency and effectiveness to the national security and space communities. That's what we were set out to do. So can we find a place where we can achieve that vision better and can be as good a home for our employees as we have here, and be as good a home for our customers as we have here, and be a reasonable deal for our shareholders? So those were really the 4 tenets. And we set out, like as I said, we started with, it started off with Ansys. We went on a kind of a 2-year path, the traditional things with investment bankers and talking to lots and lots of people, and ended up back with Ansys. So that's really it. We really had no intention of selling the company, but here we are.
So what do you think the future of AGI is under the umbrella of Ansys going forward?
Yeah, we're very excited about that, honestly, and we saw that, and it's why we went to Ansys in the first place and had that initial partnering discussion, and kind of in the 2 years since, and certainly since the acquisition we closed on December 1st, it's only became more apparent about really the exciting thing there. So again, I think many in this audience know AGI and STK, but fundamentally, what we do is we model things at the systems level, so aircraft and satellites and ships and missiles and things like that, radars, et cetera. We model we then go up to a system of systems level, so we combine multiples of those, and then we look at those in the context of the mission, and we can do the trade-offs of system or system of systems against the mission objectives. If you look at what Ansys does, Ansys goes to a much higher degree of fidelity they'll go all the way down to the chip level. So they do multi-physics, digital engineering simulation. So the multi-physics, they cover structural, mechanical, optical, RF, thermal, sure I'm leaving something out, fluids. And they do that at multiple levels. So they go all the way down to the chip level, chip, like a chip, a circuit board, a subsystem, and then they go up but they stop really at like the systems level. So the beauty here and why the future of AGI and Ansys together is, I think, much brighter than both of ours on their own, is that those two stacks kind of fit on top of each other really well. So if you look at now, you go chip, and an example I like to cite is, imagine a chip that goes on a circuit board that goes in a guidance, navigation, and control system that goes into a satellite that's part of a constellation of satellites to perform some mission. Let's say it's Earth imaging. So now with our system and system of systems and mission analysis sitting on top of their stack, going from the chip all the way up to the systems level, and then kind of joining us together at the systems level, all the trade-off, all the analysis that needs to happen down at, let's say, a chip level can be understood. Those design traits can be understood in the context of mission. So a simple example of this, imagine that we're looking at a heat sink on a chip in that GNC subsystem on a satellite. Well, design engineer looking, maybe he or she needs to change the dimensions on that heat sink to fit in somewhere, but he or she really doesn't know what the impact of that change might be on mission. Maybe it's okay, maybe it isn't. And so lots of other considerations go kind of untested because they don't have that ability. And typically what most engineers do, they'll be very conservative and they'll end up kind of over designing things. When our products kind of fit on top of the Ansys products, now you can look at that heat sink change and what happens when that heat sink, let's say, gets smaller in this case. Does that GNC system then overheat as this, let's say, this imaging system is kind of going through the motions and its attitude is changing? Maybe its solar panel is shading some parts of the spacecraft as it's going through its mission. Does that thermal load, that changing thermal load, get handled by that change in that heat sink? So that to me is kind of really the magic that happens, and we're really excited about what that brings to both to our customers. So we've already had lots of discussions with our customers now about what that's going to do for them, that increased analysis. And then also we're very excited about the additional customers that Ansys serves that's outside of our core markets. So customers that are doing things in, say, automotive, or that are doing things in 5G or Internet of Things, because all of these things kind of have those same considerations. So we're really excited about the future of AGI and Ansys.
So I think at this point I'd like to pass it over to our audience, and I see we have a couple of questions coming in. So let me start with Courtney. Courtney Stade, you have a question?
Yeah, Sally, can you hear me, Paul?
We can.
No, I sure can, Courtney.
Terrific.
Hello, Courtney.
Hi. It's terrific hearing you're going back, particularly during the early days. And I was wondering, going back to those very early days in terms of funding, did you self-finance, customer finance, venture? And I asked that wondering, amongst our audience, today's commercial space entrepreneurs, what lessons would you have sort of top level? And how did you maintain control after all these years? I'm sure you got approached a number of times to dilute and so forth. So thank you.
Yep. Okay, so we have a half an hour for this answer, right, Sally? 32 minutes maybe. No, in all seriousness, no, there is an awful lot there, Courtney. Yeah, and it is really critical. I will say it was we learned an awful lot. You know, we were 3 software/aerospace engineers. And we found ourselves in an environment that we really didn't understand at all. So what happened, we basically, the overview here is we did every sort of financing mechanism we could find. And it was difficult. We started with self-financing. So we kind of gathered up all the money that we could. And as I mentioned, it's one thing when you've got kind of like Scott Reynolds and his wife Carol and myself and my wife Shirley, without any children, we could kind of risk it all, and so we kind of slid all the chips, every nickel we had in. Jim and Judith, on the other hand, had kids in college and they really couldn't do that. So that was kind of one tough lesson learned along the way. There is, understand kind of what you're getting into that way. We actually thought we were going to get a commercial bank loan early on, and we didn't. And that was a big surprise, a big shock for us. And so then we started looking into everything. We did the credit card thing and running up the credit cards. And it's funny, just from a personality perspective, I've always been the one. I don't worry about risk too much. My wife, on the other hand, takes care of that for us. And so I'm, cleaning out the bank accounts and spending up all the credit cards, and Shirley's freaking out, and I'm just, whatever, doesn't even hit me. But then we started looking around and found some low interest state-backed loans and got a bunch of those. And of course we did second mortgages on the house, et cetera. So that kind of limped us along early on, and we self-funded through to the point of positive cash flow, which for us started about 3 years in. So it was pretty dicey from January of '89 until sometime in 92. And then from that point, we brought on a couple of new products, and we were able to stay more or less cash flow positive. We grew. Now we realized that we needed, at this point, we're kind of, on the job training, figuring this out. Hey, this capital is important. And so we ended up finding a company, a venture capital company that was specialized in space. And the company was called SpaceVest. We were this first deal that they had done of their first fund. And that fueled, we got $2.5 million of venture capital in. And that was, at the time, relative to our sales, we were right about $2.5 million of sales then. So, it was very significant relative to our sales. That caused us to grow very rapidly. So we went from, that was 95, and we went from 2.5 million in 95 to just under 13 million in 98. Then, if you remember that time, a bunch of us will remember that time. That was really a heyday in space, and that was all the big and little Leo constellations coming up, so IPO was one of the opportunities for us that we looked at, and so we actually filed to go public in August of 1998. Thankfully, that didn't go. The market kind of collapsed right in front of us, and we were lucky it did, because all of the companies right before us basically blew up because the valuations at that time were just crazy and not sustainable. So they all kind of went away. So luckily we avoided that. And then following that, there was the .com craze. And that actually caused a whole nother set of issues, because we were not a .com company, and all the capital kind of went in that direction. So at that point, now we're talking about 98, 99, 2000, we said, hey, we've got to just go on our own here. And so we dialed back our expenses and focused on generating revenue. And basically from that point forward, had self-funded all of the R&D, which for us is a really heavy number. We put about 24% into R&D, and then the expansion on the sales side as well. Does that answer your question, Courtney?
Absolutely. Thank you, Paul.
Good. Thank you.
So you mentioned the large satellite constellations, and obviously, the concern we all have now with the size of these constellations. Do you have an opinion on how the government should be handling the traffic management?
Wow.
I'm sure you do.
There's a can of worms for sure, Sally. No, a lot. Actually, it's really a big opportunity, and I do believe U.S. government has been on a great track on this for some time. I think everybody would like to be moving along faster, as most things with large bureaucracies go, I should say. But yeah, so I think specifically on the space traffic management side of that, it's been probably a good 5 or 6 years, or maybe more, where which was now the 18th Space Control Squadron, and now U.S. Space Force looking to divest from the commercial and international, basically the non-military side of space situational awareness and space domain awareness over to somebody else. So right now, it looks like the Department of Commerce actually received at least a small amount of funding to get going on that. And that absolutely seems like the right thing. Many of us know Kevin O'Connell, who really has worked in this industry for decades. And he really did a great job of moving that along quite a bit. Hopefully, with that little bit of funding, some work will be happening where the Department of Commerce will take over for a good amount of the we may have lost our image here, but take over for a good. We'll get that image back on here in a minute. We hope. Department of Commerce will take over that space traffic management work. There's several commercial companies that would love to step in. We're one of them, and part of a consortium that's hoping to help Department of Commerce come in and build a prototype of a space traffic management system that will offload that non-military function from U.S. Space Force.
It looks like we have you back now, Paul. So we can see your smiling face. Right. Let me pass it over to Eric Stromer, who has a question.
Great. Hello, Eric.
Hey, Paul. How are you? Great to see you.
I'm very well. Great. I wish I could see you too, Eric.
Oh, well, no, I don't know if that's true. That's true. No one ever. Hey, you talked about a little bit, the early days and people bringing in and then the washers and dryers and what. You really went above and beyond before it was trendy to go in above and beyond on taking care of your employees. And I speak from experience with that, knowing firsthand how far you went. But can and I think it's evidenced by the numerous awards and best places to work. The 30 years that AGI was always a place that people wanted to work and they didn't leave for the longest time. So can you talk about that a little bit? What you did to keep people in Exton, Pennsylvania, sure. and to build such a great team. So, and congratulations
thank you
on the great deal.
Thank you, Eric. And for the audience that doesn't know, Eric worked for us for a long time, and he was a great member of our family. And then some great opportunities opened up for him, and he left, but still is a great friend of the company. So. And thanks for asking that way, Eric. Yeah, I think that at the root of it, it is really a very important part of our culture, and I think any company's culture is how it is that everybody feels about each other. You really feel great about coming into work every day, working with the people that you're working and doing the things that you're doing, and that. That really, I think, sprung out of, again, the fact that it was three friends that started the company. We brought more friends into the company. New people we didn't know became friends quickly, and that was across, with the employees and with their spouses and significant others and children, and so I think it's. With the focus on that and recognizing how fundamental that human connection is with people, I think that's really what allowed us to develop that. As you mentioned, we're off the beaten track. We're in Exton, Pennsylvania, and that's about 30-40 minutes outside of Philadelphia, and it's not a hub for aerospace by any means, and it's not even a software technology hub, but it is a great place to live, and when you have a bunch of people that you really love to work with, it becomes this magnet that kind of keeps people there. I think I'll mention Eric is one of the examples of that. So So Eric is still a reserve, is that right? Army Reserve officer. And during his tenure with us, he spent quite a bit of time as serving the nation, including getting deployed. And what happened here, all of us, every person at AGI was really very concerned about that, wanted to make sure that Eric and his family, his wife at the time, wife now, and children. I don't think you had children when you were deployed, if I remember that right, Eric. And so everybody kind of poured out their hearts to Amy, Eric's wife, and to Eric himself, with lots of connection to him overseas. I remember Eric was always our guy who organized a lot of our gatherings in Washington for us. And I remember very clearly one of them, everybody, AGIers as well as all the people, the guests there, missed him so much that we took one of those cardboard cutout figures and we put Eric's face on there. And then we put a book out for everybody to write a bit in that we then sent overseas to Eric while he was deployed. So I think it's those kind of things that really, in my view, makes a real difference. It's that human to human connection that completely changes the game.
And Paul, I don't know if you're looking at the chat, but Eric made the statement that you are without a doubt the best boss in the space industry. So
I'm not sure about that.
Those human connections definitely paid off.
Yeah.
So let me pass it over to our sponsor, Dave Hebert, where he has some questions.
Thank you. Paul, kind of picking up on the large constellation comment in question, this concept of fleet management through on-orbit servicing is kind of on my mind here, thinking about what you've built and done. I'm curious, from a technology, a policy, and or a business model perspective, you could pick one, two, all three. What do you see as being the game changers to making rendezvous and proximity operations for on-orbit servicing more commonplace, where this is no longer kind of a revolutionary thing that at this point we've seen Northrop Grumman do, but becoming just the way we do business in space?
Is a big question, Dave, and yeah, concur that this is really important as we look at where we're going now in space and the proliferation of systems, and it's really all orbit regimes, LEO, MEO, GEO, and even cislunar now, and certainly all of us, many on the call here know this a lot better than I do. The systems, the way we've built them, it's you launch them one and they're done. If they're out of fuel or some minor component breaks, you're out of luck. We do have some notable exceptions to that. So Hubble, what an incredible save that was on the Hubble spacecraft mission there. But yeah, there are a lot of things to get done. So you mentioned the technical side, kind of. There's the political side and the business model side of this. So technically, so I'll try a little bit on each of them, Dave. So on the technical side, so yeah, there's an awful lot going on, and Astroscale is right at the forefront of this. But to be able to do the types of rendezvous proximity operations that you do very close in there, to be able to grapple, to be able to do things like plug into fuel tanks and refuel spacecraft or change components. Tremendous capability required there. Now, what we're seeing in these early days is some great examples of that as these missions have gone off and tested, and I think we really are going to get past the technical hurdles there quite a bit. Looking over my shoulders here in the comms block, one of the critical areas is the understanding, the space domain awareness understanding that's required to do those kind of rendezvous prox ops where you're going right down to zero distance from your targets. You really have to know where your spacecraft is and where your customer spacecraft is. to a much higher degree of accuracy than most of these systems know today. But again, the commercial players, including ourselves, are making great strides there in increasing that accuracy and being able to do what it takes from the orbital side of a rendezvous prox ops mission. Politically, there's a big issue about service, about how close you get to spacecraft. Now, in the case of on-orbit servicing, you really have the permission of the operator to do that. But still, there are going to be norms. So, for instance, if there's a high degree of risk, even if a customer is given permission for a system like yours, Dave, to approach that closely, the chance of a collision and then the debris that could result from that is non-zero. And so there are going to be government oversight or some sort of oversight there to help balance that risk versus reward. But again, I think we're already there. You're already seeing that certainly on the national security side. You're seeing some governments testing some of these systems right up to zero and grappling. So I think we'll figure out a way past that. The business model, to me, I mean, certainly that's the way the whole idea started. These spacecraft, pick it depending on where you are. It could be $1 billion spacecraft. It could be a couple $100 million spacecraft. It seems that it should be pretty easy to justify the cost of a servicing mission as compared to the cost of the spacecraft. And then you look at things like just what that does regarding the space environment. So you don't have to launch another spacecraft. You don't have to either deorbit a spacecraft or supersync a geosynchronous spacecraft if you can service it and extend its lifetime. So I think that's something that we're absolutely going to be seeing here as these next few years progress in this marketplace.
So we have a question from Alexis Schotterbeck. Alexis?
Hello, yes. I am interning with Lockheed Martin this year, and I am also a graduate student taking a class on space strategy. I was wondering if Paul could comment maybe on some broad predictions a couple decades into the future of what low Earth orbit is going to look like, integrating both military and commercial space ventures. Thank you.
Yeah, thanks, Alexis. Yeah, it is. It's already very crowded and certainly getting much more so now. I think it's great that you point out both the commercial side of that and the national security side. I think both of those, both of those, and again, I'm saying things that many on the call here really already know. But you look at the huge constellations that are actually being launched now. Was it yesterday, the day before, right? Another 60 going up. So you got a lot of spacecraft going up there. The constellations are it's a different economic situation than it was in the 90s, where back then it really, at the end of the day, that marketplace couldn't have supported, and there was a lot of elements of that. There were things like handset costs and size, et cetera. But all of that now, 20 plus years later, is a completely different situation. And the ability to bring internet access to anybody in the world, it's much more economically viable. When you look at what we'll be able to do with all the geospatial information that'll be able to come back from all the various imaging systems, electro-optical, radar, et cetera, even things like Hawkeye 360 with commercial signals are all kind of viable business models now. So you're going to see more and more and more of those. Certainly the Space Development Agency also picked up on the opportunity to leverage everything from the assembly lines to all the engineering that goes into those large constellations. And so at a minimum, the United States should be picking up the flow on these constellations too. So yeah, it is going to, it doesn't take, it just like the 90s, There's a bunch of systems that are proposed that won't actually come to life. However, many of them will, and so you're going to see a very crowded low Earth orbit environment. It's already very crowded. When you look at where most of the debris is now, it's mostly down in low Earth orbit, and now you throw in constellations that could go up to tens of thousands of spacecraft each, and that's very, very significant. So it's an issue, and there's a lot of problems that need to be worked. Sally, you also asked the space traffic management question. That's a big one. When you've got, let's just take one element of that. So now you have a satellite constellation that's many hundreds, if not many thousands of satellites. And that constellation needs to maintain itself in just the right configuration. Well, that means that you've got those thousands of spacecraft that are constantly doing maneuvers. So you don't know exactly where they are. You can't predict them simply from the Keplerian motion of those spacecraft. So now the space traffic management problem becomes very, very large. So it's an issue, but again, I do believe that we're now positioned that the technology is here and the business models are here, that we can handle this going forward, and astroscale may be helping us to clean up the larger pieces of debris in low Earth orbit, that so they don't become many tens of thousands of smaller pieces of debris. So the pieces are falling in place.
So I think we have time for probably 2 more questions. So let me take it over to Kathy Trimble.
Hi, thanks so much. I just wanted to see if Paul, what are your thoughts on digital engineering? Any near-term opportunities, risks? Is this a game changer or a force multiplier as identified in the title of this event? I'd really appreciate your thoughts.
Right.
Thank you.
Right. Yeah. Thank you. Yes. It is really incredible. And I think there are phenomenal opportunities, and I think especially for our industry. So if you look at this through our lens, we've kind of been doing our thing, which we term digital mission engineering. So it's using software products to understand the mission level issues going on with the things moving through space and time. What did open up our eyes to this much broader view of what digital engineering is going to be doing was when we really started getting involved with Ansys and looking at just that much higher level of fidelity, going down to, again, like the levels as I mentioned before, or even staying up in our level. I'll give you an example. So with STK, it's really very straightforward to be able to model transmitters and receivers on things, and you could model a bunch of characteristics of those transmitters and receivers, and even the antennas that are on those systems. Ansys, on the other hand, then takes it to a whole nother level, because they can then do a very high fidelity modeling of the entire RF environment around that near field in the spacecraft, and understanding how things like solar panels and other things on the spacecraft can affect that RF signal. Well, now the ability to really understand how it is that some particular system is going to behave at that much different level of physics, much lower level physics, is really going to be a breakthrough, and we're seeing it already in where we're interacting with Ansys as we start to look for the connection points between our software and their software in these early stages. We're seeing that already, and many of our customers are hungry for that, and so I think it's going to be game changing. So to sum that all up, I guess I'll say it this way. So there was really a big freight train running on digital engineering that was kind of outside of the kind of things that AGI had been doing, and it cut across. And I think a lot of people on the phone might be saying, well, geez, Paul, were you asleep in all those conferences that you've been to? Of course, we've been doing that. But we've been so focused on our freight train running along on the digital mission engineering that we didn't really understand what the combination of that did. So I really do believe it's going to be kind of a multiplicative effect. All the great value that has already been going on in digital engineering, combining in the digital mission engineering on top of that, and I think it's going to be just incredible. And that means that the systems are going to be in all, it's going to be up and to the right on everything, on reliability, on capability, cost effectiveness, longevity, et cetera.
Okay, so we have time for the very last question from Courtney. Take it away, Courtney.
Oh, you thought you got rid of me, but I have just a final question about the satellite congestion issue in LEO. I'm sure you're familiar with the great work Professor Jha, I believe, if I'm pronouncing it correctly, University of Texas. He's testified with Kevin and others about the severe challenges with conjunctions and so forth. And his thesis has been that in the terrestrial regulatory world, we treat scooters and trucks and other domains differently. Somehow in space, we treat everything the same. Wondering if you could have your Harry Potter wand here for a second, knowing the satellite world as well as you do, what sorts of regulatory and technical actions should the U.S. international community be taking near term to begin to mitigate what Professor Jha and others are warning us about could be a pretty severe challenge up there in LEO? So thank you.
Yeah, a great question, Courtney. And I'm not sure. Yeah, Mariba is probably way better. Mariba Jha, way better positioned probably to answer a question like that, and several others are. But I'll take a swing at it nonetheless. So yeah, there are an awful lot of complexities here when we start talking about how we're actually going to do space traffic management, how we're going to create an environment that's as safe as it can be, yet remains economically viable and allows individual nations to meet their national security needs. So there's a lot that we're going to have to work our way through here to optimize all of those issues. I think it's pretty gnarly, and there's been countless conferences for decades and decades on this issue. Standards certainly are one of the means that you can get there, and there have been there's a lot of good work that has been done, and a lot of additional work that is being done right now to help with that. There's as technology continues to increase, again, the problem will become less and less severe. So I'll just give you one example of that. So right now, if you take a look in geosynchronous space, generally, if you're not a single operator locating that's operating spacecraft together, you generally have to keep the spacecraft at least a half a degree of separation apart. That's really primarily driven by the ability to understand where your spacecraft is and understand where all the other people's spacecraft are, and including non-operative, junk essentially. Well, as the capabilities increase, where we'll have higher and higher levels of fidelity on all of that information, where that spacecraft is, where the space junk is, and be able to know with higher certainty whether or not a conjunction, where there are two things coming together, is too close. Well, that's going to open up more orbital space for more spacecraft. That's, again, just one example, but. When you look across, you've got the commercial issues to deal with there, which kind of was mostly the example I was using, primarily commercial. You've got the national security issues. So, how close do you really want an adversary spacecraft getting to your spacecraft? And what about when one nation wants to do that to another nation, but doesn't want that nation to do it to them, right? So there are all these things that have to be considered there, but it is one of the biggest issues. And by the way, I think it's one of the things that Washington Space Business Roundtable ought to really dig further down into. I think that having a dialogue in this kind of a venue about these issues would be really very valuable to the entire world in this area.
Thank you, Paul.
We're going to have to close it there. Thank you, Paul, very much. We really appreciate you taking the time to come and answer all our questions. And hopefully we're going to see you at future WSBR events.
I'd love to, Sally. Thank you.
Really appreciate it.